Your bones will start dissolving after 6 months. The radiation will give you cancer. The toxic dust will shred your lungs. The journey alone has a 50% chance of killing you before you even arrive. And yet, right now, thousands of people are volunteering to be the first humans to colonize Mars, knowing they'll probably never come home alive. Welcome to humanity's most audacious suicide mission, space mission. Mars colonization isn't just difficult. It's the ultimate test of whether human ingenuity can overcome physics, biology, and basic survival instincts. Here's what we're up against. Mars is a frozen desert with no breathable air, deadly radiation bombardment, and soil so toxic it could kill you just from touching it. The average temperature is 80°F. A single dust storm can cover the entire planet for months. And oh yeah, it takes 6 to 9 months just to get there. Assuming your rocket doesn't explode, your life support doesn't fail, and solar radiation doesn't fry your DNA. But here's the crazy part, we're not just talking about visiting Mars, we're talking about living there permanently. Building cities, raising children, creating an entirely new branch of human civilization on a world that actively wants to kill us every single day. SpaceX says they'll have people on Mars by 2029. NASA is planning crewed missions for the 2030s. Multiple nations are racing to be first. Private companies are investing billions, and regular people, engineers, doctors, teachers are literally signing up to leave Earth forever. This isn't science fiction anymore. This is happening. The question isn't whether we'll try to colonize Mars. The question is, can the human species actually pull off the most dangerous migration in history? Before you can even think about surviving on Mars, you have to survive getting there. And the journey to Mars is essentially a 6 to 9 month long Russian roulette game with physics. Picture this. You're sealed inside a metal tube barely larger than a small apartment, hurtling through the vacuum of space at 25,000 miles per hour. Outside, the temperature swings from 250°F in sunlight to 250°F in shadow. There's no air, no gravity, and enough radiation to give you a lethal dose if your shielding fails. Your bones start losing density within weeks. Without Earth's gravity constantly pulling on your skeleton, your body begins cannibalizing itself. Astronauts on the International Space Station lose 1–2 of their bone mass every month. On a Mars journey, you could lose 20% of your bone density before you even land. Meanwhile, your muscles are atrophying. Your heart, no longer working against gravity, begins to weaken. Your vision starts to blur as fluid shifts in your body affect your eyes. Some astronauts develop permanent vision problems that never fully recover. But the real killer is radiation. Earth's magnetic field protects us from cosmic rays, high-energy particles that can literally tear through DNA. In space, you're completely exposed. Every day of the journey, you're getting bombarded with the equivalent of several chest X-rays worth of radiation. By the time you reach Mars, your cancer risk has increased by 3–5, and that's assuming everything goes perfectly. No equipment failures, no solar flares. No psychological breakdowns from being trapped in a can with the same people for 9 months while Earth becomes just another star in the darkness. Congratulations! You've survived the journey. Now welcome to Mars, a world that makes Antarctica look like a tropical vacation. The moment you step outside your landing craft, Mars begins trying to kill you. The atmosphere is 95% carbon dioxide with virtually no oxygen. Take off your helmet and you'll be unconscious in 15 seconds, dead in 2 minutes. But suffocation is the least of your problems. The atmospheric pressure is less than 1% of Earth's. That means your blood will literally boil if you're exposed to the Martian atmosphere. Your saliva will bubble on your tongue. Any moisture on your skin will flash vaporize. It's like being in the vacuum of space, but somehow worse because there's just enough atmosphere to create violent weather. Speaking of weather, dust storms on Mars can cover the entire planet and last 4 months. These aren't gentle Earth dust storms, they are continent-sized hurricanes of razor-sharp particles that can sandblast equipment and block out the sun completely. The dust is so fine it gets into everything. Your equipment, your habitat, your lungs. And that dust? It's toxic. Martian soil contains chemicals called perchlorates, the same stuff used in rocket fuel and explosives. Get it on your skin, and it can cause thyroid problems. Breathe it in, and it can damage your lungs permanently. Every time you come inside from the Martian surface, you're tracking in poison. The temperature swings are brutal. While Earth's thick atmosphere moderates temperature changes, Mars's thin atmosphere can't hold heat. You might experience a pleasant 70°F during a summer afternoon, but that same night it could drop to 100°F. Your equipment has to survive these temperature swings every single day. On Earth, we're protected by something invisible but vital, our magnetic field. It's like having a planetary force field that deflects most of the dangerous radiation from space. Mars has no such protection. Every single day on Mars, you're being bombarded with enough radiation to significantly increase your cancer risk. Standing on the Martian surface is like getting a chest X-ray every few days for the rest of your life. Work outside for a full Martian year, and you'll have absorbed more radiation than nuclear workers are allowed in their entire careers. But it gets worse. Solar flares, massive eruptions from the sun can deliver lethal doses of radiation in hours. On Earth, our magnetic field deflects most of this. On Mars, a major solar flare could kill unprotected colonists in a single day. Imagine living in a world where the weather forecast includes deadly radiation storm likely Tuesday. The only solution is shielding, and that means mass lots of it. You'd need several feet of Martian soil, concrete, or metal between you and space at all times. Your entire colony would essentially have to be built underground or buried under tons of regolith. This isn't just about cancer risk decades in the future. Radiation exposure affects your immune system, making you more susceptible to infections. It can cause cataracts, skin damage, and neurological problems. Some scientists worry that the radiation levels on Mars could cause cognitive impairment, making colonists gradually less able to solve the complex problems necessary for survival. And here is the truly terrifying part. We don't fully understand the long-term effects of chronic radiation exposure at Mars levels. The colonists won't just be pioneers. They'll be test subjects in a grand experiment on what radiation does to human beings over years and decades. Mars has 38% of Earth's gravity, which sounds manageable until you realize your body has been perfectly evolved for Earth gravity over millions of years. On Mars, everything about how your body works begins to break down. Your bones, constantly stressed by Earth's gravity, start dissolving without that constant pull. Calcium leaches out of your skeleton and into your bloodstream, where it can cause kidney stones and cardiovascular problems. Your bone density drops month after month, potentially reaching the point where a simple fall could cause multiple fractures. Your muscles, no longer working against full gravity, begin to atrophy. But this isn't just about getting weaker, your heart is a muscle too. In reduced gravity, your cardiovascular system doesn't have to work as hard, which sounds good until you realize your heart is literally getting weaker every day. The effects go deeper than just bones and muscles. Your inner ear, which helps with balance and spatial orientation, gets confused by the different gravity. Some colonists might experience constant dizziness or motion sickness that never fully goes away. But here's the real trap. These changes might be irreversible. Astronauts who spend months on the International Space Station can recover most of their bone and muscle mass when they return to Earth. But what about people who spend years or decades in Martian gravity? What about children born on Mars? A child born and raised in Martian gravity might never be able to visit Earth. Their bones and muscles, developed under Mars gravity, might not be strong enough to function under Earth's stronger pull. We could be creating a permanent new branch of humanity, Martians who are physically adapted to Mars and can never return to their ancestral home. You can't eat Martian soil. You can't hunt Martian animals because there aren't any. You can't forage for Martian plants because they don't exist. Every single calorie a Mars colony needs to survive has to either be brought from Earth or grown in artificial conditions that don't exist anywhere in nature. Let's talk numbers. A single person needs about 2,000 calories per day. A small colony of 100 people needs 200,000 calories every single day, or 73 million calories per year. That's roughly 40 tons of food annually. And that's assuming nothing goes wrong, no crop failures, no equipment breakdowns, no contamination events. Growing food on Mars isn't like gardening on Earth. First, you need soil, and Martian regolith doesn't qualify. It's full of toxic perchlorates and lacks the organic matter and beneficial microorganisms that plants need. Every ounce of growing medium has to be created artificially or brought from Earth. Then there's water. While Mars has water ice, it's often located in harsh conditions near the poles or deep underground. Extracting, purifying, and transporting enough water for drinking, cooking, and agriculture is a massive engineering challenge. Your crops need protection from radiation, temperature extremes, and the toxic atmosphere. That means enclosed, pressurized growing facilities with artificial lighting, climate control, and air filtration. Every tomato grown on Mars requires a high-tech life support system. But here's the killer. You can't afford crop failures. On Earth, a bad harvest means higher food prices. On Mars, a bad harvest means people starve to death. There's no backup plan, no supply runs from the neighboring planet, no emergency food aid. Your agricultural systems have to work perfectly, year after year, or people die. Mars colonization isn't just about surviving, it is about building and maintaining incredibly complex technology in one of the most hostile environments imaginable, millions of miles from any repair shop. Every piece of equipment a Mars colony depends on, from life support systems to communication arrays to power generators, has to work flawlessly for years with no possibility of replacement parts from Earth. A supply mission from Earth takes 6 to 9 months and costs hundreds of millions of dollars. You can't just order a new oxygen recycler on Amazon Prime. This means every critical system needs multiple backups, and colonists need to be able to manufacture replacement parts using only materials available on Mars. Imagine trying to run a modern city, but you can only use materials you can mine and process locally, and if anything critical breaks, everyone dies. The engineering challenges are staggering. You need power systems that can survive dust storms lasting months. You need life support systems that can recycle air and water with near-perfect efficiency. You need manufacturing capabilities that can produce everything from computer chips to medical equipment. And it all has to work in conditions that destroy equipment. The temperature swings expand and contract materials until they crack. The fine Martian dust gets into everything, jamming moving parts and abrading surfaces. Radiation degrades electronics over time. Everything wears out faster and breaks more often than it would on Earth. But here's the real gamble. Much of this technology doesn't exist yet, at least not in forms suitable for Mars. We're betting that we can invent, test, and perfect incredibly complex systems, then deploy them on another planet where failure means death. It's like trying to build a submarine while already underwater. The human mind wasn't designed for Mars. We evolved in environments with blue skies, green plants, flowing water, and the sounds of life all around us. Mars is a silent, sterile, red wasteland where the sky is the color of rust and nothing moves except wind and dust. Imagine never again seeing a bird, hearing rain, or feeling natural sunlight on your skin. Imagine living your entire life in enclosed spaces, breathing recycled air, drinking recycled water, surrounded by the same small group of people every single day. Now imagine knowing you can never go home. Antarctic research stations give us a preview of what Mars colonization might do to the human psyche. Even with the knowledge that rescue is possible and rotation home is scheduled, researchers in isolated polar stations experience higher rates of depression, anxiety, and interpersonal conflict. They know their isolation is temporary. Mars colonists won't have that comfort. The sensory deprivation is profound. Mars has no complex weather patterns like Earth's ever-changing cloudscapes. No seasons in the way Earth experiences them. No diverse landscapes beyond endless variations of red rock and dust. The psychological impact of living in such a monotonous environment for years or decades is unknown. Then there's the social pressure. In a small colony where everyone's survival depends on everyone else functioning perfectly, there's no room for mental health breaks, personality conflicts, or psychological crises. A single person having a breakdown could jeopardize the entire colony. And what about children? Kids who grow up knowing they'll never see Earth, never experience natural weather, never swim in an ocean or climb a tree. How does that shape their psychology? How do you raise mentally healthy humans in an environment that's fundamentally alien to our species? Let's talk money, because Mars colonization isn't just technically challenging, it's economically insane. Current estimates put the cost of getting a single person to Mars at between 1 billion and 10 billion. That's not including the cost of keeping them alive once they get there. To put this in perspective, it costs about 10,000 per pound to launch something into Earth orbit. Mars missions require much more fuel, more complex spacecraft, and longer mission durations. Getting a 200-pound person to Mars, along with their life support systems, food, water, and equipment, could easily cost more than most countries' entire annual GDP. But the real economic challenge isn't the initial cost, it's sustainability. A Mars colony has to eventually become economically self-sufficient, or it remains forever dependent on massive subsidies from Earth. What does Mars produce that Earth wants to buy? The traditional answer is scientific research, but that's not enough to support a large colony. Mars has minerals, but so does Earth, and Earth's minerals don't require a 9-month journey and billion-dollar infrastructure to extract. Mars has very little that Earth needs and can't get more easily elsewhere. This creates a fundamental economic paradox. Mars colonies need massive investment to become viable, but they have no clear path to profitability that would justify that investment. It is like trying to build a city in Antarctica and expecting it to pay for itself through ice exports. The only scenarios where Mars colonization makes economic sense involve either revolutionary breakthroughs in space travel costs or treating it as insurance for human civilization, essentially an incredibly expensive backup plan in case something catastrophic happens to Earth. After everything we've discussed, the radiation, the toxic environment, the crushing costs, the psychological challenges, the technological hurdles, you might wonder why anyone would attempt Mars colonization at all. The answer reveals something fundamental about human nature. We are an exploring species. We are a problem-solving species. We are a species that looks at the impossible and says, let's figure out how to do it anyway. Every great human achievement started as someone's impossible dream. Flying was impossible until the Wright brothers did it. Going to the moon was impossible until Apollo 11. Curing diseases was impossible until we invented antibiotics and vaccines. Connecting the entire world through instant communication was impossible until the internet. Mars colonization represents the ultimate expression of human ambition, the decision to become a multiplanetary species, not because it's easy, but precisely because it's hard, not because the rewards are immediate, but because the long-term implications are profound. There's also the existential argument. Earth faces potential catastrophic risks from asteroids, supervolcanoes, climate change, or human-caused disasters. A self-sufficient Mars colony would serve as a backup for human civilization, expensive insurance, but insurance against the extinction of our entire species. But perhaps most importantly, Mars colonization will drive technological innovation that benefits life on Earth. The closed-loop life support systems developed for Mars could revolutionize sustainability on Earth. The medical advances needed to keep humans healthy in space could extend lifespans everywhere. The engineering solutions for Mars could solve problems we haven't even recognized yet. Mars colonization is humanity's next great chapter, not because we have to, but because we can. Because we're the species that looks at a frozen, irradiated desert millions of miles away and says, let's build a city there. And somehow, impossibly, we probably will.